Earth Networks is a part of the Advanced Environmental Monitoring family of companies, and we operate the world's largest proprietary weather observation and lightning detection networks. Our vision is a safer and more prosperous world, and we help global organizations automate decisions through weather intelligence. And every fall, our meteorologists analyze trends and forecasts to create the Earth Network's winter outlook, and it's a collaborative effort from this amazing team. And this is your 2021-2022 Winter Outlook team. And we provide 24/7 custom threat forecasts and seasonal outlooks just like this one for governments, major sports teams, schools, aviation, and enterprise clients, among others. And today's outlook will be presented by senior meteorologist Chad Merrill and meteorologist Dan Rupp. Chad Merrill joined Earth Networks in 2008, and he has a Bachelor of Science degree in meteorology from California University of Pennsylvania. Dan Rupp joined Earth Networks in 2019. He has a Bachelor of Science in Meteorology from the Pennsylvania State University. And they both produce custom forecasts for a wide range of clients around the US and around the world. And now it's my pleasure to hand it over to Dan so he can start the outlook. So Dan, here you go.
Okay. All right, thank you very much, Anna. Just get control here, gonna turn this on. All right, thanks for joining us, everybody. We're gonna start with the winter trends across the US. And on the left, you can see our minimum temperature trends across the US along the eastern coast here. See over the last 30 years during the winter season, we have a warming trend, especially for the Northeast, a little bit of a cooling trend here, but not too much of a strong signal, but you see some blues there highlighted indicating a little bit of a cooling for the low temperatures. Towards the west, see some areas of some warming, and then the high temperature trends for the winter, definitely a stronger signal for the northern plains, and that could be from some of the strong Arctic outbreaks that occur here during some winters. And to the west, there's a warming signal over there, and that might have to do with the ongoing drought and just some warming temperatures occurring over there. And the south as well, the southeast showing a warming temperature trend. So you put those two together, you get the average trends. You see the southeast, some warm signals, northeast, so pretty similar to both graphics. And then the cooling trend right there for the northern mountains there, Montana, Wyoming, and into the northern plains. For the precipitation, this does include rain and melted down snow and ice, quite the signal of more precipitation occurring since the 90s here for the Mississippi Valley and into Alabama and Georgia and all the way up into the Great Lakes. But further out to the west, you have that, of course, that ongoing drought that's meaning less precipitation over time. This is a map showing the coldest period of winter across the US. So this is just averages dating back from the last climate normals. And you see towards the west, they start to see their coldest period of winter in December. So they're the first ones up. And as you go into the mountains here, their coldest period is for into January and further out to the east. So the west, it has likely something to do with the maritime air. And also, they have their radiational cooling. They're losing heat overnight with the more the dry period there, but we're starting to get into a little bit more precipitation, as you can probably notice when you're looking at the radar out there. If you do, they're starting to get some atmospheric river events, more precipitation, and that's bringing the temperatures down. But towards the central part of the US and the east, they start to see their coldest period later on in January, and that's just because the Arctic air takes a while to build up, and the coldest air of the season then comes down when the jet stream dips, and you start to see the coldest air at that time. Of course, you get further south, you're battling with the length of day as you get towards Florida. But notice here in the Great Lakes, they see their coldest period of winter towards the end of January, see your legend here, and into February. And that's because the lakes, the moderating effects of the Great Lakes, they keep them warmer for a longer period. But then once you get later in the season, the lakes sometimes freeze over, and then that could bring, that allows the coldest air to start to settle in over in that area. And just a note, it looks like the last big freeze of the lakes was in 2019, had about 80% ice coverage there, but we are seeing some years where you don't get a whole lot of ice coverage like last year. So moving on to the snowfall trends showing across the US, we selected a few cities here in different areas. We'll start with the West, and this is going through 30-year normals, and these change every 10 years. So you see you have 71 to 2000, 81 to 2010, and 91 to 2020. And of course, there will be a new one once we head into 2030, but this is showing the trends over time. You can see a lot of Western cities are actually losing snow. So Flagstaff seeing a decrease in snowfall, Denver, Salt Lake City, Albuquerque, and Seattle. As you go further to the east, Minneapolis seeing a decrease in snow. Bismarck, not much of a trend there. That's staying about the same. Kansas City, still about the same there, at least since '81. Nashville and Dallas seeing a little bit of a slight decrease. Now this is interesting. Once you go further east, you see some mid-Atlantic cities, New England cities, and you're noticing that they are seeing an increase in snowfall. One example is Boston, even into Pittsburgh, New York City, DC, not much of a change, and then Asheville there seeing a little bit of a decrease. And chances are this is from nor'easters just picking up more moisture and dropping more snowfall, some pretty strong events that you can get sometimes along the coast there. Pittsburgh, that's probably a lot of some of the lake effect that they get from Lake Erie and other lakes, and also maybe a little bit of a trend of some of the low pressures tracking a little bit further to the west. And then as we look at some Great Lake cities, Syracuse, slight increase in snowfall. Marquette, they had a kind of a outlier year here, a lot of snowfall happening in the latest normals. Watertown, New York there, Muskegon, seeing a decrease in Erie, Pennsylvania, seeing an increase in snowfall. And, you know, lake ice has just been kind of decreasing on average over time, and that's extending the lake effect season. So that allows more snowfall to fall in some of those areas downwind. Not every lake effect city, but a lot of the cities that are getting that northwesterly, northerly flow, they're seeing a little bit of an increase in snowfall there. So when we're getting to our winter outlook, just keep in mind that our forecast can be based on the months from December and all the way through March. And we're also going to be looking at anomalies or departure from averages for precipitation and temperature across the contiguous US. So what are our leading factors for this winter outlook? Well, the one we're weighing the most, of course, is ENSO, the El Nino Southern Oscillation. We're weighing that one at 40% for our forecast. Analog winters weighed at 30%, decadal trends at 20%, and the QBO, or the quasi-biennial oscillation, at 10%. I'll talk about the ENSO here in just a second, and Chad's going to go over these with you in just a few minutes here. So the ENSO, we're going to start with that. Let's see here. I think we got a little bit of, we're hung up here for a second. I don't know, Anna, if you can. There we go. Yeah, let's just get to the next slide there. Yeah, if you can change the next slide, it looks like I'm hung up a little there. Might just have to change the next slide for me. Hey, Anna, do you have control? Are you able to? There we go. All right, fantastic. Sorry about that. All right, let's get rolling here, shall we? So which phase of the ENSO is expected this winter? Well, we expect the La Nina to dominate again this winter, just like last winter. We did have some cooler sea surface temperatures in the equatorial Pacific, and you can see on our map here, the blues indicating that we do have, in fact, some cooler than average temperatures, and that can give us a a lot of effects downwind of that and into the United States for this winter season. All right, let's see if we can go to the next slide there, Anna. Apparently I lost control there. Okay. So the forecast model predictions of ENSO through March, you'll notice that we started to get into La Nina towards the end of September and October. We started to see some cooler sea surface temperatures, and the forecast models show that we will in fact stay in La Nina. Now towards the tail end of winter, we could start to trend into neutral territory, but chances are that's not going to matter too much because of that lagging effect. So even though if we go into a neutral phase, we're most likely going to continue to see effects of La Nina since it takes some time for the atmosphere to adjust to that new phase. Go to the next one. All right, so the models, they're showing, basically this is for each month. On the left-hand side, you see all of your different models right here for the month of December. And this is showing, most of the models are showing all La Nina phase. January, same deal. February, starting to see a little departure towards the neutral phase. And then March, maybe we're seeing some of these models are indicating a neutral phase, but you know, some of them are still saying it's going to be leaning on the cooler side. So pretty much a borderline neutral to a weak La Nina. All right, go to the next one. All right, so typical winter La Nina impacts. Well, we have the jet stream right here that dips down. You have that colder air to the north, and you have that low pressure track that tracks across the jet stream, and that's why we have this wetter pattern. And then you have some of those atmospheric rivers that can affect the Pacific Northwest, and towards the south, that subtropical jet starts to lack, and it's not as strong, sometimes even non-existent, and that creates a drier and warmer than normal for the southern U.S. All right, and the cold warm upside potential during La Nina winters. So these are basically showing the odds of seeing those warmer than average temperatures across the U.S. So this is December through February. You see the southern U.S. Strong indication there for warmer than normal temperatures, and then some cooler than average chances up here towards the north. Same with January through March, same deal. Pacific Northwest and the southern U.S. Both seeing the colder than average and then the warmer than average temperatures respectively. So typical La Nina pattern as you look at those. And we'll do the next one. This is your precipitation, and you see the drier than normal for the southern U.S., some indications of more precipitation and snow for the mountains in the Pacific Northwest, northern plains. And as you go through the January through March period, you see in the Great Lakes into the Appalachians a little bit here, and the central U.S. seeing below average precipitation, same with Texas and Florida. All right, so now we're going to talk about our next wave factor, the analog years, and I'm going to hand this over to Chad to go through this with you.
And thank you so much, Dan. Yeah, we looked at years that will mirror what we expect for the 2021-2022 winter across the U.S. So the analog years that we chose for our winter outlook basically hinged on two things. The first one that Dan touched on was the La Nina that we expect, and the other one is the pattern of sea surface temperatures in the North Pacific called the Pacific Decadal Oscillation. On the left-hand side is a typical cold phase of the PDO, where you have colder than average temperatures along the Alaskan coast and the Bering Sea, contrasted with much warmer temperatures in the North Pacific adjacent to that water. We are definitely in a cold pattern with that horseshoe of cooler than average sea surface temperatures in the North Pacific, contrasted with the warmer sea surface temperatures to the south. And what happens is, with the negative phase of the PDO, it enhances the typical effects of a La Nina. So in those graphics that Dan showed with the extreme outcomes, warm outcome to the south and a wet outcome to the north, is what you typically would see when I say enhancing the typical effects of a La Nina. So as we go forward here in the next slide, this slide focuses on the weak La Nina winters coupled with the negative phase of the Pacific Decadal Oscillation. And again, we're looking at the most recent 30 years, 1991 to 2020 climate averages. There's a strong signal for cooler than average temperatures here from the Northwest into the Northern Rockies and to also the upper Mississippi Valley. That cold signal fades very quickly south of Interstate 70. And precipitation, there's a strong signal for above average precipitation in the form of high mountain cascade snow, coastal and valley rain in the Northwest, and also the Northern Rockies. The other strong signal for above average precipitation is across the Tennessee Valley into parts of the Midwest. And there is a stark contrast between the Northwest and California, where you have below average precipitation, which would include mountain snow in the Sierra, all the way through California into the Southwest. Southwest had a little bit of a monsoon help this past summer, and looks like once we go into the winter time with a typical La Nina and a negative PDO, there's less precipitation than average. That would be rain, of course, for most of the desert locations and mountain snow in the northern parts of Arizona. Also a signal for drier than average conditions in Texas and the southern plains, and also in the state of Florida. So as we go on here to the next slide, what you're going to see is the decadal trends. These are noteworthy winter temperature and precipitation trends over the last 10 years. So we see the temperature outcome on the left and the precipitation on the right in terms of the last 10 winters across the US. And there has been a trend for drier conditions across California and also parts of the Southwest in terms of precipitation, and across parts of the upper Midwest into the Tennessee Valley. There has been a trend for above average precipitation, some of that being snow, of course, in the Great Lakes. And if we could, oh, there we go. So there's that strong signal for above average precipitation in the Tennessee Valley. Florida has seen a strong signal for below average rainfall, same with Texas and along the California coast into the Southwest. As Dan mentioned, the prolonged drought that has been happening across much of the West. There we see those strong signals for above average precipitation in the Northwest. The Mid-Atlantic's divided a bit. Above average precipitation in the form of some rain and some sleet and snow west of the Appalachians into the Ohio Valley, and then slightly below average precipitation right there along the southeast New England coast. So those are the temperature and precipitation trends over the last 10 winters. And as we continue on here, what we'll see is our final deciding factor, which we weighed at 10%, is the quasi-biennial oscillation, which could dictate temperature patterns for part of the winter. And the slide next will show what a typical QBO is. So you probably never heard the term before, but it's basically an oscillating wind that goes from west to east about 6 miles above the equator. But in the winter time, depending on which phase it's in, negative phase is an easterly wind and a positive phase is a westerly wind. What happens is it also impacts or transfers its energy to the Arctic Circle and impacts what's called the stratospheric polar vortex. Again, this is wind at 6 miles above the surface. So this is just a diagram of how it can impact the stratospheric polar vortex. On the next slide that we are going to see is the phase that it's in. It's been negative since June of 2021, and the typical cycle for a negative phase and or a positive phase lasts 14 months. So we expect it to continue right through March as in a negative phase or an easterly wind. And research has shown that when you have an easterly phase of the QBO, you tend to get what's called big fluctuations in the jet stream, north to south fluctuations in the jet stream that can lead to cold outbreaks in the US. But a negative QBO does not imply that it's going to be the sustained cold is going to last through the entire season. So with that in mind, let's take a look at the next slide. And here are 4 common temperature patterns in North American winters. The Arctic high regime on the upper left is associated with what we would consider a weak polar vortex, which is more likely to happen in a negative QBO winter. So what typically happens is you have blocking across Canada, and that creates above average temperatures across the northern plains. And the cold air and the storm track focuses the best precipitation and the best chance for cooler temperatures across Texas and parts of the southeast. So last winter, you may remember the brutal cold that Texas experienced. That was because we had a stratospheric warming event over the stratosphere, the North Pole or the Arctic Circle, and that created this particular regime. So that cold outbreak was due to the Arctic high regime in a weakened polar vortex state. Now, an Arctic low regime is when you have a very strong polar vortex and you get below average temperatures across the west and above average temperatures across the east. Now, in a Pacific trough, you get cooler than average temperatures in the northwest, some of that due to cloud cover and precipitation, and very warm across much of the east. Florida trends slightly cooler and usually has a little bit more in the way of precipitation. The cooler temperatures are due to the enhanced chance for some precipitation in the form of rain. And now the Alaska ridge regime results in cold air that blasts down into the east coast, and you have warm temperatures out west. So in a typical winter, you can go through these different phases that I'm showing you, and that is usually indicative of a north-south fluctuation in the jet stream. So these are the different weather patterns that we can have during the winter time, and the two that are linked to a weak stratospheric polar vortex when in a negative QBO winter is the Arctic high regime in the upper left-hand corner, and to some extent, if the polar vortex is elongated, the Alaska ridge regime. Now these, on average, these patterns last 5 days to a couple of weeks, so they're not sustainable through the entire season. On the next graphic here, we are going to show, here's the outcome of a negative QBO and a weak La Nina winter. Instead of the axis of cold air being centered from the northwest into the central Rockies, it's centered from the northern Rockies into the Midwest. And precipitation, you tend to see below average precipitation, California into the southwest, into Texas. Again, that signal has been prevalent in the slides that we have been showing with the analog years, as you recall a couple of slides ago. So there is still that signal present across the southern plains into the southwest, into Southern California. However, a different outcome in the northwest, below average precipitation and a negative QBO and weak La Nina winter, and below average precipitation here across the Ohio Valley and Tennessee Valley. There's a lot of noise interference across the mid-south. You have the above average precipitation contrasted with the below average precipitation from the Boot Heel all the way into southern Arkansas. So there's some noise generated there in that particular part of the country, but the temperature pattern is definitely very similar in the northern Rockies. It just differs once you get into the central Rockies and then the Midwest, depending on where the cold pattern tends to shift. So as we go on to the next slide here, what we're going to do is put it all together and show you our final product, the winter outlook for 2021-2022. And based on the factors that we have weighed, here is a look at the temperatures that we expect, the temperature anomalies for the winter of 2021-2022. Basically from the northwest into the northern plains, we are predicting below average temperatures from a combination of some brief Arctic spells that will come south. Now these will probably be short-lived, but they will happen this winter, and an active storm track. So from Washington State, northern Oregon, into the central parts of the Rockies, into the Great Lakes, we forecast below average temperatures, and even into parts of northern New England as well. We do expect above average temperatures from Texas into the southeast and along the mid-Atlantic coast. There will be a couple of cold blasts that move into the east, but they will be transient. They will be short-lived. They won't be sustainable throughout the entire season. Again, keep in mind, this is a December through March forecast. So even if you have a cold December and you have a mild or near average January, but then you have a very warm February and March in Dallas or, for example, Memphis or Washington, D.C., those warm anomalies are likely going to, or the cold anomalies, I should say, will diminish, and you'll be left with overall temperature scheme of above average temperatures. So we are expecting basically the northern part of the US to see below average temperatures and then above average across the southern plains into the southeast and mid-Atlantic coast. As we go to the next slide, here's the forecast for precipitation across the US. And it's going to look very similar to a La Nina pattern. Above average snowfall in the northern Rockies, also the northern Cascades, above average precipitation, some of that being lake effect snow across the Great Lakes, a bit of that being rain in some of the lower elevations and some of the southern areas south of I-70. So above average precipitation in the form of snow, sleet, freezing rain here across the Midwest and Ohio Valley, below average across the Southwest into the Southern Plains and Florida. So what this means as we go to the next slide is that the drought will be chipped away across the Northwest and Northern Rockies. The drought will persist as we go into the Great Basin, California, most of the Rockies, Central and Southern Rockies, and expand out into the Southern Plains at least through the end of January. Drought will probably develop not to the magnitude that the West is having, but in Florida, places like Orlando down to Miami will likely be in a DO or D1, which is abnormally dry or perhaps a moderate drought. This is through the end of January, but this would likely persist through February and maybe even the first part of March. So this is not good news for the Southwest, which did get help from the monsoon season this past summer, but it is good news for Northern California into Washington and Oregon, and also the northern parts of the Rockies. So as we go into the next slide here, how does this look compared to last winter? Basically a flip-flop in the temperatures. Northern Plains, instead of being above average, we expect below average temperatures. And then in Texas, which saw the cold weather in February into the first part of March, we'll see above average temperatures for the entire season. So the temperature pattern will be flip-flopped this winter compared to last year. When we look at the precipitation, how it compares to last year, in certain areas of the country, it actually will be very similar to last year's La Nina pattern. Texas did have a cold winter last winter, but below average precipitation, and that's what we expect for this winter. So the temperature map, or the precipitation map, will look very similar in Texas, and also parts of the Northwest, which had above average precipitation. It will also look very similar from California into Texas. Probably those higher anomalies with precipitation in the Central Plains will be diminished this winter. We do expect another winter of above average precipitation. So Tennessee and Kentucky, very similar to last winter. We don't expect the magnitude of precipitation along the Carolina coast, so that will be diminished a bit. And Florida will look very similar to last winter with below average precipitation.